Hello everyone, back tuning into the 9th Winter 2018-19 updates from GWV.com. So we've done 8 of these updates since the start of September. We've got 13 updates penciled in, so we really are coming to the business end of the winter updates now. We've only got updates 10, 11, 12 and 13 to do before we get to the winter forecast. We'll be releasing winter forecast at GWV on Sunday, the 2nd of December. So getting quite interesting now, and as I say, we are reaching the important points within these winter updates. So the idea of this is that each update is important in its own terms, but it's also building up a bigger picture. But when we get to the forecast, we'll bring all of these updates together and we'll be able forensically to go through each methodology and pick out the best years compared to this year, and then hopefully be able to release a successful winter forecast. Now, to go along with that, we also have 3 seasonal model roundups in September, October, November, and at the end of the updates, when we get to the forecast on the 2nd of December, we will combine the seasonal models with the winter updates, with the methodology, and hopefully we'll be able to bring you a successful winter 2018-19 forecast. So it's getting ever closer now to the crunch, and we'll have to start getting a little bit serious in the next few weeks. But still trying to have a bit of fun. That's what we're going to do for today's 9th update. So we're going to pick up exactly where we left off last week, talking about ENSO and having a look at El Nino analogs. So there's a lot more to come on that, and then we'll go through all of the other things that we look at: solar activity, Siberian snow cover, and all of that kind of thing. So it's going to be a long video, this. If you can't watch it all in one go, don't worry, it will be kept at GWV indefinitely. Later on today, this video will be placed on the winter updates and forecast page, and there'll be an extensive written summary that goes with it as well. So you'll be able to come back and watch the video whenever you want on demand, and you'll also be able to have a read of that written summary as well. But if you're going to watch it all in one go, it's going to be a long video, so get a comfy chair, get a cup of tea, and get whatever you would like to snack on with this 9th Winter 2018-19 update. I hope you enjoy it. Just say a big thank you to James Acriel, as ever. Our analogs guru has really come through for us again this update, getting all of the analogs together. I couldn't do the winter updates without James's input, getting all of the analogs together and the solar tracker. So as ever, a big thank you to GWV's analogs guru, James Acriel. And without further ado, let's get on with the 9th Winter 2018-19 update. So we're going to begin talking about ENSO again. You remember last week we went through the El Nino analogs. We looked at various scenarios for El Nino, and they came out as pretty interesting analogs. It was the most sort of coldest set of analogs that we've had within these winter updates were suggested in last week's 8th update, which was an El Nino special. We've got more to add to it, though. We're going to be talking about either normal El Ninos or Modoki or Modoki El Ninos. So I'll just explain what a Modoki or what a normal El Nino is. So El Nino is the cyclical warming of the equatorial Pacific Ocean from Peru over towards Indonesia. We've got Peru over here and Indonesia over here. The equatorial Pacific warms and cools in cycles, and these warming and cooling events are called El Nino in terms of warm events and La Nina in terms of cold events. Essentially, it's one of the ways that the Earth warms and cools itself. It's the Earth's natural thermostat at work, if you like. So when you're in an El Nino, you are releasing warmth out of the tropical Pacific Ocean, and then you'll distribute it around the planet. Conversely, when you are in a La Nina, you're releasing cold into the planet via the ocean system. So it's kind of like the Earth's thermostat being turned up and then being turned down again. Now, usually El Nino will be relatively uniform in terms of the warming from east over on the Peruvian side to west over towards the Indonesian side. Sometimes, in fact very often, you'll find that the warmest of the waters is over in the eastern side. Sometimes, however, you can get a Modoki or a central-based El Nino, and what happens then is that the central part of the equatorial Pacific, kind of like this region just here, which we call the 3.4 region, the central part of the equatorial Pacific will be warmer than the eastern part of the equatorial Pacific over towards Peru. So this is regions 1 and 2 just here, and then this is regions 3.4. I may be a little bit out with those areas, but essentially 3.4 is central part of the equatorial Pacific Ocean. 1 and 2 is the eastern part. And when you find it becoming warmer here through the central part of the equatorial Pacific compared to here, where it's cooler, we call that a central-based or a Modoki El Nino. So a lot of people don't realise that you can get various versions of El Nino, or at least you get two versions of El Nino, with a general uniform El Nino, where it would typically be warmest in the eastern part of the equatorial Pacific Ocean, or a Modoki or a central El Nino. Now, the El Nino that we think we're going to have for this winter, albeit it is going to be quite a weak one, is being forecast to be a Modoki, a central-based El Nino. So this is region 3.4, which is, as I say, the central part of the equatorial Pacific Ocean. This is the forecast of a CFSV2 for region 3.4. And you can see that the black dash line here is around 1 degree above average. So let's just move this up a little bit so you can see the dates. So we've got the temperature anomalies for region 3.4 of the equatorial Pacific Ocean on the side, with the monthly periods along the bottom. So to get an El Nino, you have to be around half a degree or more above average, basically. So you're in this sort of realm, around 1 degree above average. You're kind of like at weak El Nino threshold. When you're around 1.5 degrees above average, you're at moderate El Nino threshold. When you're at 2 degrees above average, you're at strong El Nino threshold. And then when you're above 2 degrees, you're kind of like going into Super Nino type territory, which is quite rare, but we have had 3 of those since 1983. This is not going to be a Super Nino. It's not even going to be a strong Nino. If we do have an El Nino designated, it will be a weak El Nino. The black dash line here, which is the ensemble mean from the CFS V2 model, is going up to around 1 degree above average through the remainder of this year and into the start of 2019. So around 1 degree above average for region 3.4 is CFSV2 forecast. But we see that regions 1 and 2, which is that eastern part of the equatorial Pacific, are a little bit under that. We do just about get to 1 degree above average very shortly, probably around November. The black dash line is just about struggling towards 1 degree above average. But overall, this black dash line is underneath 1 degree above average. It's around between 1 degree and 1.5 degree and half a degree above average. So it's cooler in the eastern part of the equatorial Pacific, regions 1 and 2, compared to the central part of the equatorial Pacific. And that would be a weak Modoki El Nino, a weak central-based El Nino. ECWF is showing this as well. Again, this is the forecast from the ECMWF model for region 3.4, the central part of the equatorial Pacific. Again, same idea, dates on the bottom, temperature anomalies on the side. That's 2 degrees above average there. That's 1 degree above average, and that's ENSO neutral just there. So you can see the broad sort of thrust around the start of the year for region 3.4 with this ensemble plume is somewhere around there. So it's kind of like into weak or possibly borderline moderate El Nino threshold. It's a little bit stronger actually now, the ECMWF, compared to what the CFS-V2 is showing for that central part of the equatorial Pacific. But if I show you regions 1 and 2 over towards the Peruvian side, again, you can see that the broad thrust of the ensemble plume, again, we're looking for around sort of November, December, January. And the broad thrust of the ensemble plume is kind of like in there at this point for the end of the year, which is struggling to get to 1 degree above average. So I think quite conclusively, both CFS-V2 and the ECMWF are going for Modoki, central-based El Nino here by the time we get through to the end of the year. So what would that mean? What's the difference between a general El Nino, a normal El Nino, and a Modoki El Nino? Well, through reanalysis, we can show you. So we're going to start off by showing you normal El Nino. So this is when it's either going to be warmest in the eastern part of the equatorial Pacific Ocean. It'll just be uniform warm across the equatorial Pacific Ocean. So these are normal El Ninos, and we're starting with the winter of 1902-1903. We have above average heights in this winter down to the south of the UK, with below average heights out to the northwest. So this is a mild winter, bringing up the air from the west or the southwest. That's a mild winter in 1902-1903. Probably quite unsettled in the north, but fairly dry down in the south. The next normal El Nino is 1904-1905. This one has above average heights out to the west of the country, below average heights up to the north, and the flow of the jet is coming through, something a little bit like that. So a lot of dry weather with that winter, probably a little bit cooler than the first winter, but not a cold winter at all because we haven't got any blocking signal whatsoever to the north of the country. The next normal El Nino is 1905-1906. This one looks unsettled with below average heights to the northwest and bring the Atlantic through like that, rather an Atlantic driven, and I would think fairly mildish winter there as well. 1911-1912 is another normal El Nino, and again we have the below average heights out to the west, and we bring in this westerly to southwesterly flow. There is a little bit of blocking signal around Green, but nowhere near strong enough to overpower that low pressure in the Atlantic. So it's a wet and mild winter for 1911-1912. The next normal El Nino is 1913-1914, and this one looks quite unsettled with below average heights close to the country, but again not favouring anything particularly cold with that one. 1918-1919 turns up next. Now for this one we do have a stronger blocking signal. We have more in the way of high pressure going on up here. We have the below average heights in the Atlantic and going into Europe rather like that. So we're closer to colder conditions. I think there was some cold weather in the winter of 1918-1919, but the main thing is that this winter is quite a wet winter. Then we're through to 1925-1926. Again, it looks like we're into quite a Atlantic-driven type pattern with the flow coming through like that in the winter of 1925-1926. 1930-1931 is our next winter with below average heights through the UK and to the east. And then we get above average heights in the middle of the Atlantic and going up towards the northern Atlantic as well, bringing the flow and the jet down. Something like that. So there's, again, very unsettled looking winter, that one, and a little bit colder as well, I think, for 1930, 1931. Now, this is our first genuinely cold winter with a normal El Nino, and this is the winter of 1939, 1940, that ferociously cold and severe winter at the beginning of the Second World War. This one has a very, very strong blocking signal up to the north of the British Isles. It has these below average heights in the Atlantic. The jet stream, therefore, is down here somewhere. We're pulling in severely cold air at times from the east or the northeast. That's a very cold winter in 1940. We go all the way from February 1895 to January 1940 before we get a negative CET month. So it was a long run through the early decades of the 20th century, but we went without a negative CET month. January 1940 was the coldest month, therefore, since February 1895. And of course, we know that the 1940s did have several cold winters after that also. The next normal El Nino is 1951, 1952, and we get the below average heights to the east of the country with the above average heights out to the west. That leaves us pulling down the winds from a northerly direction. That's a rather colder winter, but nowhere near as severe as 1940, of course, because there's no real blocking signal, but there was some cold weather at times. This is 1953, 1954. Let's try to get a little bit more interesting now, these winters. We find with this one, we've got a Scandinavian high dominating to our northeast, where we've got this red area, and then we've got the below average heights down to the south, and that leaves us pulling in these easterly winds. It starts off mild in the winter of 1953, 1954, but it gets a lot colder by the time we get through to the end of winter, particularly February 1954. This one's also another pretty coldish winter. This is 1957, 1958, with a normal El Nino. We get the below average heights to the northeast and the above average heights for blocking signal to the south of Greenland. Again, this one comes late with the cold weather. It's reasonably mild through December 1957, but by the end of February and indeed into March, turns very cold in 1958. The next normal El Nino is 58-59, so this one does have a blocking signal to the north of the country, actually, with below average heights in the Atlantic and going to the southwest. There is some cold weather in with this one. January 1959 is quite cold. Then we're up to winter of 1965, 1966. This is again normal El Nino winter with the below average heights rushing through the country. But there is a blocking signal up to the north. What happens with this one is that the cold is earlier on. So there's quite a bit of cold weather in December 1965, and especially around Christmas. And then also January has quite a freeze up at one point through January 1966. But by February, it actually gets fairly mild with quite an early-ish spring. Then we're up to 69-70, quite an interesting winter because it has a blocking signal up to the north and below average heights down to the south, and we pull down the wind from the northeast. That has its moments, the winter of 69-70, particularly late on. End of February into March, we get hit by some very cold and snowy weather. 72-73 comes up next. This is just a mild winter, really. There is a cold snap at the beginning of February 1973, but overall this one is mild and fairly dry as well, bringing in me sort of southerly to southeasterly type winds with that one. Then we're up to 76-77. So I talked about this a lot. It's been cropping up a lot in the updates recently this year. So this one, again, it has a cold weather early. In December 1976, we get the cold weather, and some degree in January 1977 as well. Then it gets much milder as you get through to February. Very, very cold winter on the eastern side of America. I think it's their coldest winter on record for many of those eastern states, and snowiest as well. For us in the UK, we have it early with the cold weather, and then we go into a milder interlude. This is the first Super Nino. This is the first Super El Nino winter of 82-83. Again, it's a normal El Nino. It's not a Modoki. It's a normal El Nino, but it's a very, very strong event with the above average heights out to the west, below average heights to the north. It's a rather mild, stormy winter overall, but it does get colder from February, and it's a very cold spring in 1983. Then we're up to our next Super El Nino, which is the El Nino of 1997-1998. And this one, very mild winter with above average heights to our east and south, below average heights in the Atlantic. We bring up those long fetched southerly southwesterly winds, exceptionally mild winter, especially so in February, where we get temperatures close to 20 degrees on Valentine's Day. 1998. And then we're up to another Super Nino, the last one that we had, which is 2000, actually this is 2014-15, so just before that Super Nino. This is the winter of 2014-15. This one rather Atlantic driven. I'm getting ahead of myself. I'll talk about that last Super Nino in a moment. But this is 2014-15 with the below average heights up to the north, the above average heights out to the west and southwest, and we bring in the westerly flow. Some way similar to 82, 83. There is colder weather in there. We do have a few cold snaps, but overall 2014-15 is not remembered as a cold winter. And then we are up to the Super Nino, the last one of 2015, 2016. And this one, exceptionally mild winter. Again, we get the high pressure to the south. Rather a bizarre looking 500 millibar height anomaly profile, really. Quite a strong blocking signal up here, but it's all overridden by this high pressure to the south. And then, of course, we've got this deep low pressure. Let's change colour. We've got this deep low pressure out to the west of the country, and that leaves us bringing in these long effect southwesterly winds. We know it has the warmest December that has ever been recorded in CET history, back to 1659, but January and February 2016 are also very mild months as well. So if we bring it all together, this is how a normal El Nino looks in December. It looks very unsettled with the below average heights through the country. You expect a wet but not particularly cold December because there's no northern blocking signal. January looks like that, and we do see an increase in the blocking signal during January. So there are months in there are January's within this analogs package that would be cold, but overall it's not a particularly cold signal because we're mainly being dominated by the below average heights to the southwest. It is close to it though, it is close to it being a cold signal, but I think overall the January's favour rather mild and wet conditions. As do the Februaries. The Februaries also have a blocking signal to the south of Greenland, but we get the below average heights coming through the country and overriding that blocking. It's not really until we get to the March that you could say we probably do have the greatest chance of cold weather. We do see a big strengthening of the blocking signal in March, with high pressure setting up around Greenland, and then the below average heights are underneath it, and that has the greatest chance anyway of being cold. Bearing in mind, there are, within that analogs package, I mean, there are cold Decembers, and December probably has the least chance of being a cold month. I mean, there's December 1976 for starters, which was a cold month. So even in December, there is a small chance of colder conditions, but it looks as though the risk with these normal El Ninos of colder conditions grows the further on into winter we go. That's how the anomaly comes out overall for these normal El Nino winters, with again the below average heights over to the west of the country, a little bit of a blocking signal but not all that strong. Therefore we favour relatively mild and wet weather with normal El Nino. But what about Modoki El Nino? What about those central based El Ninos where it's warmer in the middle of the equatorial Pacific and cooler over towards the Peruvian side? Let's go through those next. So we come back to 1914, 1915, which looks like a very wet winter indeed. This is an exceptionally wet winter with a trough of low pressure part over the top of the country, and we bring in a lot of wet weather from off the Atlantic with that Modoki El Nino. Then we go through to 1923, 1924, and this one is a cold winter for much of Central Europe. Actually, doesn't quite come together for the UK. It's actually a relatively mild winter for the UK, but it is close actually to being a cold winter. I know that some central parts of Europe and Western Europe did have some cold weather. 1940, 1941 shows up next with again the below average heights to the southeast, the blocking signal up there towards Greenland, and therefore with this one we're pulling down those very cold east or northeasterly winds. And then can you believe the next Modoki El Nino is 41, 42. So it's really interesting actually. Within these El Nino analogues we've got the trilogy. We've got the three cold winters in the early 1940s. Got 39, 40 for the normal El Ninos. It was quite a weak El Nino, that one. For the normal El Ninos, we've got 39-40. Then for the Modoki El Ninos, we've got 40-41 and 41-42. So that's the hat trick. That's the trilogy of very cold winters in the early 1940s. This one has the blocking signal more to the northwest of the country, with the below average heights to the east. But nevertheless, it's still very cold winter. And again, 3 very cold Januaries, 1940, 1941, 1942. The next Modoki El Nino is 63-64. This one with below average heights down to the southwest. We get the blocking up to the north of the country, and a lot of dry weather with this. It's having a go at getting into the pattern we had in the winter before, 62-63. But it just doesn't quite get there, and it's rather a quiet and dry winter. There is some cold weather at times, but of course greatly overshadowed by 1963. And then look at this, we've got our next Madoki El Nino is 68-69, and this one again with that strong blocking signal around Greenland, but below average heights underneath it. That's a cold winter in 68-69. It has a white Christmas in parts of the country in 1968, but it has a very cold and snowy February in 1969. 1977-1978 is the next Madoki El Nino, so that's a little bit wrong up in the browser. Let's quickly flip that over. So that should be 1977-1978. And again, this is a pretty cold winter, actually. It has below average heights to the south, has quite a strong blocking signal up to the north. It starts off quite mild in December 1977. It gets colder and colder as we go along. We do actually have quite a cold February in 1978 with quite a bit of snow. The next Madoki El Nino Winter is 79-80. This has been cropping up quite a lot in the analogues package just recently. It looks like it should be a cold winter, but it wasn't a particularly cold winter, but it does have quite a lot of high pressure to the north of the country. 1987-1988 is the next Madoki El Nino, and this is not a very good one if you want a cold winter. It does actually, maybe a little bit surprisingly, have a bit of a blocking signal up to the north, but overall it's a mild and wet winter in 1987-1988. Very, very little snow at all in that winter, and of course it's the first of the trilogy of very mild winters in the late 1980s. 1990-1991 shows up next, so this is another cold winter. Definitely these Modoki El Ninos are favouring colder winters compared to the normal El Ninos. I think we can quite easily demonstrate that further on we're going. So this is 1991. Of course, we get the high pressure over Scandinavia, and particularly in February, we have exceptionally cold freeze up in February 1991. 1994-1995 is the next Madoki El Nino with low pressure to the north and high pressure to the south. This is a mild Atlantic-driven winter. So you see that Madoki El Ninos, whilst they probably do favour colder winters, they don't guarantee it. There are examples here. 1988, 1995 are definite examples where we don't get cold winters even with a Madoki El Nino. 2002-2003 is the next one. Again, the below average heights to the southwest. We've got the above average heights to the northeast. We bring those winds in from an easterly direction. With that one, looks like it should be a cold winter, but it wasn't particularly in 02-03. This is 2004-2005. It has above average heights out to our west. Bring down the flow from the northwest. That's quite an interesting winter. It's fairly mild early on, although December 2004 has a white Christmas. And then it gets cold through February and into March 2005. And then finally, the last time we had a Madoki El Nino was in 2010, 2009, with the blocking signal around Greenland, and of course we have the below average heights to our south, very reminiscent of those early 1940s winter, particularly 39-40, I suppose. But we finish up, the last Madoki El Nino was a cold winter in 2009, 2010. Let's put those together, and this is how the Decembers are coming out. Much greater chance of being colder in the Decembers, with above average heights over Scandinavia, below average heights to the south of the country. Both the high pressure and the low pressure are quite weak signals, but obviously compared to the Decembers with normal El Ninos, have a much greater chance of colder conditions in the Decembers. That's how the Januaries look. Again, much more in the way of blocking in the Januaries with these Modoki El Ninos. So we've got high pressure from Greenland, it does extend to Scandinavia as well, and low pressures to the south. We bring those winds in from an easterly direction in the Januaries. That's the Februaries. Again, you see the below average heights more to the south of the country, very strong blocking in the Februaries around Greenland, and also going to the north of the country. Again, these look really, really good, these analogues, to favour colder conditions. And then we're through to the Marches. And again, looks like we extend the winter out into the Marches with these, as we get the blocking signal around Greenland and Iceland. And then we have the below average heights to the south. The jet stream is down there somewhere, and we're favouring bringing in those winds from an easterly direction. Putting it together, we find that for these Modoki El Nino winters, much greater chance of being cold, with below average heights to the north and a strong, to the south I should say, below average heights to the south, and a strong blocking signal to the north of the country. And so, yes, it looks like the Modoki El Ninos very much favouring a cold winter compared to the normal El Ninos. Really, really interesting analogues package there, and a big thanks to James for sending those through. So if you want a cold winter, I think you want to be favouring Modoki El Nino, but keep in mind that within the Modoki El Nino analogues, there are winters that are mild, 1994, 1995, 1987, 1988. Conversely, within the normal El Ninos, there are also winters that are cold, such as 1939, 1940. So we're talking about probability here, what favours the most probable outcome, but there is never a guarantee with the weather. Right, so that's our analogues package for this week. I'll pause the video there. We'll talk for half an hour. Pause the video, go and get yourself a little drink of water. We'll meet back in around 2 minutes' time, and we'll go through everything else. We'll have a look at the rest of the sea surface temperature anomalies for the ocean. We'll see what's happening with solar activity and Siberian snow cover as well, amongst other things. So come back in around 2 minutes' time, and we'll continue with the 9th Winter 2018-19 update. Okay, we're back, and we're going to continue the 9th Winter 2018-19 update from GWV.com. So the first half hour of the 9th update, we talked about El Nino. I think we're pretty much exhausted El Nino over the 2 updates. Can you believe over 2 updates we've had an hour's worth of El Nino analogues? So we were talking about the difference between normal El Ninos and Modoki El Ninos. The modelling is favouring a weak Modoki El Nino in terms of CFSV2 and the ECMWF anyway. And we just was establishing that a weak El Nino, if it's Modoki, does favour a cold winter. Not a guarantee. There are, of course, as always, other factors that we need to take into account. That's why we're going to do the rest of the methodology for you right now. But overall, a weak Modoki El Nino looks like it favours the chance of a colder winter. So get on with the rest of the 9th update for you now. We're going to continue having a look at the oceans. So we've got our 3 specific areas of interest that we're interested in. So we're going to see how things have panned out over the past week. We've got the ENSO region just here. We've got the Northern Pacific Ocean up there. And we've got the Atlantic Ocean, the North Atlantic Ocean over here. So that's how the sea surface temperature anomalies were looking when we did last week's 8th winter update. This is the very latest, and let's deal with the ENSO region further all. So I think we have seen a little bit of strengthening of the El Nino signal in the ENSO region. Last week, you remember, it appeared to be backing off a little bit. This week, it's actually strengthened slightly with a little bit more in way of orange here in the Equatorial Pacific Ocean. Now, I have to say, despite what we're just talking about in terms of Modoki El Nino, it does look as though the warmest anomalies to average are over here in the eastern part of the Equatorial Pacific, and it is warmer than average through the central part over towards the western part of the Equatorial Pacific, but it looks warmer over in the east. That looks like a more normal sort of El Nino signature. But bear in mind, this is the 25th of October, and we're not going to be into the winter and for another month or two. So it may be this is going to evolve itself into a situation where it will be warmer here and cooler here. That's certainly what the modelling wants to do, but we'll see how that plays out. In any case, whether it's a normal El Nino or a Modoki El Nino, is going to be a weak event if it is ever designated. The northern part of the Pacific Ocean remains a bit of a mystery. Again, that situation last week, this is the situation now. I think it's cooled down a little bit in this northern part of the Pacific Ocean, but it still remains much, much warmer than average. And we've established in previous updates that this is quite unusual, actually. It's not unusual for the past 2 or 3 years. Since 2014, this has been going on, but we've had varying degrees of warmth up here in the Northern Pacific Ocean. Last year wasn't particularly warm, 2017-18, but other than that, most of the years back to 2014 have been quite warm. But going further back than that, we've established that it is quite an unusual sort of situation to be having it as warm as this over such a long period in the Northern Pacific Ocean. So that's a little bit of an unknown for this winter, quite what effect that has. I think that what this tends to do is send the jet stream on a northwest-southeast trajectory across America. So I think for northern and eastern parts of the states, and right, we do have people watching from the states, for northern and eastern parts of the states, this is a good signal for cold weather, because you're going to push the cold out of Canada into the north and the east of the states with the jet stream on that northwest-southeast alignment. For us in the UK and Europe, it's a little bit more uncertain. We had this in the winter 2013-14 to some degree, and that winter the cold air came out of East America, hit the Atlantic, blew up the jet stream, and we had that raging jet all the way across the Atlantic into northern Europe, bringing copious amounts of rain. The critical factor, if we do get this northwest-southeast alignment, will be any blocking that we can get up to the north. If we can get high pressure in up there, then even if we have this raging jet stream coming out of the eastern coast of America, even if we've got a raging jet stream hitting the Atlantic, if we have strong blocking up here, that will force a jet stream to take that kind of track into southern Europe as opposed to going up there. So it's going to depend on how much blocking we can get going to our north. In terms of the northern Atlantic sea surface temperature anomalies, again, that's a situation last week. This is the very latest. Very little change in the North Atlantic. Things have been stable in the North Atlantic for several weeks now. To the south of Greenland, it remains quite cool. It remains fairly warm, although it has cooled down from what it was like 6 weeks ago, but it remains quite warm over towards the eastern seaboard of America. And then in the tropical Atlantic, close to average, you would say. Certainly no sign of a tripole, which is what we look for to produce a negative, or to help produce a negative NAO. If we have that, we would have it warmer and cooler and warmer. So the Atlantic sea surface temperature anomaly is a problem to get a colder winter, I have to say, but it doesn't guarantee that we won't get a colder winter. One other area that we do like to keep an eye on is the Norwegian Sea. That was a situation last week when we did the 8th update last week. This is the very latest situation. It's warmed up a little bit again in the Norwegian Sea. We had a very, very warm Norwegian Sea last year, and there is a bit of speculation that might have been one of the things that helped get us a colder winter. Looks like it's beginning to warm up again across the Norwegian Sea just at the moment. This is the 2018 Atlantic hurricane season from Wikipedia. We can scroll down and have a look at the latest numbers. So in terms of total depressions, we now stand at 16 for this tropical storm hurricane season. For total tropical storms, we stand at 15. For hurricanes, we stand at 7. And for major category 3 or above hurricanes, we stand at just 2. Been a very unusual season in that we've had quite a lot of depressions and storms actually, but not all that many hurricanes, and certainly not many major hurricanes. Those numbers, the first two are up 1. So for depressions and storms, we're up 1 on last week. For hurricanes and major hurricanes, we're unchanged. Not sure what the impacts of this are going to be. The reason we look at hurricanes, because what a hurricane is doing essentially, it's distributing heat. So we get the hurricane forming down here in the tropical Atlantic, moving in that direction. There's lots of heat, of course, in the tropical Atlantic. And as those storms form, they move through the tropical Atlantic, then push northwards, get caught up in the jet stream, and will finish off going up there somewhere. So essentially you're taking warmth from the tropics and you're moving them up into the North Pole. When you get lots of storms, lots of hurricanes, dumping lots of heat from the tropics, distributing it through the Northern Hemisphere, but particularly ending up in the pole. When you get a lot of that happening through a hurricane season, later on it can translate back, or it appears to be able to translate back into an increased risk of northern blocking for the winter. So we've had a lot of storms and depressions, but we haven't had all that many hurricanes and major hurricanes. So I'm not quite sure what the impacts of this very odd hurricane season of 2018 are going to be. We'll have to do more research. Let's look at what's happening in terms of the stratosphere over North Pole with the zonal winds. So we've got pretty strong zonal winds at the moment. This is from weatheriscool.com. And we can see that where we are right now actually is just here. This blue line here shows how the strength of the zonal winds has fared through this season so far. Dates on the bottom, of course, so that's the start of November just there. So this is kind of like November, this is December, this is January as far as we can go with the forecast. So that blue line shows where we've been with the zonal winds, actually close to or even a little bit below average with the zonal winds through September into early October. We have had strengthening of the zonal winds though now, so we're around here. We have got quite a strong zonal flow. The green lines are the GFS ensembles, and they are forecasting over the next couple of days that the zonal winds will strengthen further. But then you'll notice the GFS ensembles are dropping those zonal winds out as we get through into kind of like the second week of November. The zonal winds are weakening over the North Pole. And that's quite a dramatic drop, actually, in terms of the zonal winds. Without something like a stratospheric warming taking place to drive that, that is quite a big drop from where we are, or where we will be in the next couple of days, to where we're likely to be in around 10 days or a couple of weeks' time down there. That's quite a big drop in the strength of the zonal winds. And that could indicate, but as we go into December, we're likely to see a weakening of the westerly flow. We're likely to see a weakening of zonality. So although November might start off with quite strong westerlies being driven by this pretty strong, certainly stronger than average, zonal wind at 10 HPA in the stratosphere over the North Pole. Although we might start off with that in November, we may well, as we get further into November, see a weakening and possibly of zonal winds, and possibly increase a blocking signature. Now, the rest of the coloured lines, the three pink coloured lines and the blue coloured line, they are the long-range CFS V2 model. The forerunners of CFS V2. And what those forerunners are predicting in terms of the strength of the zonal winds. So you'll notice as we go through November, so again, this is November just here, we've got this one member just here that really is dropping out the zonal winds through the course of November and into December. If that came off, we would see a strong blocking signal, I think, setting up to the north of the country. It may even, CFS method may even be going for some sort of sudden stratospheric warming event to be taking place over the Arctic, which is very rare and unusual in November. The other members. So we've got this blue one that's kind of like keeping things pretty weak, actually, with the zonal wings. Not really collapsing the zonal wings, but certainly keeping them much weaker than average. Remember, that's average just there. And then the other two members, which are the other two pink members. So we've got that one just there, but no, it doesn't really go for weakening of the zonal wings all that much. We've got this other member just here that does weaken those zonal wings off quite a lot into the middle of November, and then strengthens them again. We do also see as we get towards, so this is going to be December just here, this is January just here, we do also see as we get towards the end of December, which is kind of like just there, that we've got this ensemble member just here, this pink one, that's collapsing things down. The other two look quite weak. And so as we go through December and particularly into January, actually most of these CFS runs are forecasting weakened zonal winds. You certainly, through December and January, you certainly wouldn't look at that and be expecting a very strong zonal flow. I've got to say, most of these CFS members are under average. We've just got this one member up here that is a little bit stronger than average through December in particular, but then that one just dropped things out as we get through to the start of January. To me, that doesn't look like a particularly strong Atlantic-driven winter, I've got to say, through this winter. So we'll keep an eye on that. But I think the main thing to focus on at the moment is this drop in the zonal winds that's coming up through the first part of November. Because, again, that's where we're going to be in a few days' time. But this is where the GFS is forecasting us to be, or GFS Ensembles forecasting us to be, by the middle of November, or just before the middle of November. That is quite a big drop in the strength of the zonal winds without a warming of the stratosphere or something like that to cause that. So it'll be interesting to see what the implications of that might be through the course of November. Solar activity next. This is the solar disc on our side of this today from solarham.net. We are completely spotless with the solar disc, no sunspots at all. Solar activity, therefore, is at very low levels, and Solarham is saying that solar activity will remain at very low levels. This is because of its 9th winter update solar activity tracker sent through by our good friend James Acriel. And we just remain at very, very weak condition, really, with this in terms of the sunspots. So this orange line is each individual day's sunspots. We can go back to November. Excuse me, we can go back to November with the solar tracker now. And you can see we are having many, many days now without any sunspots. So back in the summer, the thick green and thick red lines, they're the trend lines. We see back in the summer, back in July, we saw this pretty dramatic drop in solar activity. We flatlined through much of the second half of July and into the early part of August. We flatlined with barely any sunspots at all. Little bit of a tick up. I mean, this is still very, very low solar activity, but just a little bit of a tick up late August into start of September. But really, we can say that we have had another sort of 9 days of pretty much spotless conditions again in the solar disk, and so our trend lines remain virtually on the floor, if not quite on the floor, but virtually on the floor. It's just those odd days that are appearing with sunspots still. It's just holding up those trend lines from being right on the very floor of the tracker. But this is all really, really weak stuff. We are into solar minimum. I think we entered into solar minimum, solar cycle 24, back in the summer. We're in solar minimum now. We're going to be staying in solar minimum for this winter, and true solar minimum, and then the start of solar cycle 25 will probably occur some point through next year, probably the second half of next year. But we're at solar minimum. This is going to be a very, very weak. Solar winter, to say the least. The winter 2018-19 will be very, very weak solar winter indeed. So big thank you to James for updating the tracker as always. And then what we're going to finish off with is Siberian snow cover. So this is how things were looking across Russia and Siberia in terms of snow cover last week. Well behind most years, actually. We established, probably going to go back to 2011, maybe 2008 for a year that had as little snow cover as this, or for a year that we was ahead of in terms of Siberian snow cover. Let's have a look at the very latest. This is it. I'll just refresh the page and see if it'll refresh for us. So no, we're still updated up to the 26th of October. We've increased the snow cover a lot over the past week, quite obviously. That situation last week, the 19th of October. This is the situation as far as we can get to, 26th of October. A big increase there has taken place with Siberian snow cover. And interestingly, we've also started bringing snow cover back to Scandinavia as well. We had quite a lot of snow cover in Scandinavia in the early part of October. We lost much of that through the middle part of the month, but it's coming back now across Scandinavia. So a big increase in snow cover, yes, which you would expect because this is the time of year when Russia and Siberia will get covered with snow. A little bit unusual to see. We have got a few patches over here that, and that's in the far eastern part of Siberia, a few patches that don't have complete snow cover, and that's quite unusual for this late in the season. I think this year is still lagging behind a little bit. Let's confirm that. So we're going to go through the years back to 1998. This is how things looked across Russia and Siberia at this point in 2017, last year. Obviously, we've got much more snow cover in 2017 compared to this year, so we can see that quite definitively. We are well behind 2017 for snow cover this year. Let's start running through the years. That's 2016, and again, we're behind 2016 for total snow cover across Russia anyway, but we have got more, interestingly, over Scandinavia this year compared to 2016. That's 2015, so again we are lagging behind 2015 for Russian and Siberian snow cover, but we have got more again across Scandinavia this year. That's 2014, and well, we are well behind 2014 for this year, both in terms of Russian, Siberian snow cover and also in terms of Scandinavian snow cover as well. That's 2013, so what do you think about that? We are lagging behind 2013 as well for Russian and Siberian snow cover and also for Scandinavian snow cover too. That's 2012, so I think the Scandinavian snow cover, we're very close to 2012. I'm going to talk about 2012 a little bit in a moment, but again, that is this year. This is 2012. Very close in terms of Scandinavian snow cover, and probably quite close in terms of Russian snow cover as well to this point in 2012. That's 2011. I think we're a little bit ahead of 2011 now, actually, certainly for Scandinavian snow cover, probably for Russian and Siberian snow cover too. That's 2010. We're ahead of 2010. So let's get rid of that because it's complicating the issue. We're ahead of 2010 for this year for Russian and Siberian snow cover, and probably quite close to Scandinavian snow cover. That's 2009, so we're quite close to 2009 again for Scandinavian snow cover. We're doing well for Scandinavian snow cover, and that's going to increase more, I think, over the next few days. So we're quite close to 2009 Scandinavian snow cover, and a little bit behind, I would have thought, for Russian and Siberian snow cover. That's 2008, well ahead of both Scandinavian snow cover and Siberian snow cover for this year compared to 2008. 2008 was a very, very slow Siberian and Scandinavian snow cover season. That's 2007. We're ahead of 2007 for Scandinavian snow cover and also for Russian and Siberian snow cover. That's 2006, quite close to 2006 for Russian snow cover, and probably quite close, even a little bit behind, for Scandinavian snow cover. 2005, we're on a par with 2005 for Scandinavian snow cover. I think in terms of Russian snow cover, a little bit ahead of 2005. 2004, we're ahead of that year for Scandinavian snow cover. For Russian snow cover, we're probably quite close. So we're on a par now with many years for both Russian and Scandinavian. We have seen a big increase in snow cover over the past week. That's 2003. We're behind 2003 for Russian snow cover, and probably quite close, maybe a little bit behind even for Scandinavian snow cover. That's 2002. We're behind for both Scandinavian and for Russian. That's 2001. We're ahead of 2001 for Scandinavian snow cover, and probably a little bit behind in terms of Russian and Siberian snow cover. That's 2000, and we are well ahead of the year 2000 for Russian and Siberian snow cover, and we are well ahead of 2000 for Scandinavian snow cover as well. That's 1999, well ahead of 1999 for Scandinavian and for Russian / Siberian snow cover. And then missing for last year, 1998, and we're ahead of 1998 as well for Scandinavian and for Russian snow cover. So we've done pretty well, actually, over the past week, and we are now, after lagging behind for the earlier part of this month, we are now on a par or ahead of a lot of years, actually, in terms of both Scandinavian and also Siberian snow cover. This year appears to be playing out kind of similar to 2012, so I'll just give you a little reminder of what happened in 2012. Again, this is the snow cover chart up to as far as we can get to, which is 26th of October. I keep trying to refresh the page, see if it's updated at the Natis and NOAA website, but unfortunately it hasn't updated to show today's Saturday 27th figure. But if it did, I think we're seeing a further increase in this snow cover, so that's quite annoying that that's not happening. But anyway, that's how things are looking at the moment up to 26th of October. This is how what's that one a little bit wrong? This is how things are playing out for 2012. So that's how things looked on the 26th of October 2012. I think we are very, very close for both Siberian, Russian, and also Scandinavian snow cover as of the 26th of October 2012. But look what happened the next day, to the 27th of October 2012. We had this surge in snow cover, both into Scandinavia and also into eastern, northeastern, and even central parts of Europe. An absolute surge of snow cover. And then that continued through the closing days of October 2012. We get to the last day. You see most of Scandinavia is covered in snow. Much of northern Russia, in this western part of Russia, also covered with snow. That snow extending into the east of Europe. I've always thought what happened there through the final days of October 2012 was probably quite pivotal in terms of telling us that the Siberian high would likely be coming our way through that winter. And we know that eventually 2012-13 did turn into a very cold winter. Now, this finally is how the GFS model is forecasting snow cover to develop through the next few days across Russia. So if you think we've got the UK and Western Europe just there, we've got Scandinavia over there, and then this is the snow cover across much of Russia. So where we're interested in is this area just here, where we don't have all that much snow cover in this southern and sort of southwestern part of Russia. But look how snow cover is being forecast to increase by the GFS model in that area over the next couple of days. So we're up to the early part of next week now. You'll notice most of Scandinavia, by the time you get through to the final day of October, which is Wednesday, most of Scandinavia will be covered by snow with this forecast. Much of Western Russia is also covered by snow as well. Now, it doesn't look like we're going to get that surge into Europe that we had in 2012, but nevertheless, I think this is quite important how we're going to see, or if this forecast is right, we are likely to see snow cover increasing quite dramatically in the west of Russia and across the remainder of Scandinavia in the next few days. And that is kind of reminiscent of what happened in 2012. Not quite to the same extent, not pushing that snow line through to Eastern and Central Europe, but quite a big increase for both Western Russia and for the remainder of Scandinavia in snow cover through what's left of October. So we'll keep an eye on that, and I'll bring you up to date with how that panned out when we do next week's 10th winter update. Finally, I just want to say about patrons. So if you're enjoying the winter updates this year and you would like to consider becoming a patron for GWV and giving us an ongoing monthly donation to help fund the website and also to help fund the updates, then all you need to do is come to the GWV's Patreon page, sign up for a Patreon account, and then you can pledge whatever amount of money you would like. It can be anything from $1 a month upwards as an ongoing monthly payment. You can cancel at any time, but it's an ongoing monthly payment that you'll be giving, or donation that you'll be giving to GWV. You'll be helping us to pay for our website and keep all of the content completely free of charge. Conversely, if you would prefer to just make a one-off donation, you can do so through the GWV's PayPal page. This is here. I'm on the GWV's PayPal page right now. So you've got a PayPal account. Most people have. It's really simple. Just sign in to that, and then you can donate whatever amount of money you would like as a one-off donation, to say thank you for the updates and thank you for the content, and tell us how much you're enjoying what we're doing. So it's helping to fund the website, helping to keep all of the content completely free. We are primarily ads funded and will be remaining so. This is just like an extra revenue stream that allows us to keep the content totally free of charge to the point that you want it and you need it. And a big thank you to all of the patrons, all of the donors, GWV. You'll get a shout out in the videos. You'll get a thank you from myself, say thanks so much for your donation. A big thank you to all of the patrons and all of the donors. Right, so we're just shy of an hour, another epic winter update. I hope you're enjoying this season of updates. We are drawing, not to the end of them, but we're certainly drawing towards the final stages with the winter updates. So I just hope you're enjoying the updates this year. They're the most exhaustive, the most epic updates that we've ever done. And I know for some people it's probably a little bit too long, but you can watch them in bite sizes through the week until you get to the next update the following week. So I just hope that everybody is enjoying the updates. And a big thank you to sticking with the updates through this year. So this video will be placed on the winter updates and forecast page. There'll be an extensive written summary that goes with it as well. That'll be around 7 o'clock this evening, something like that. Between now and then, we're going to have the 4th and final written updates for Christmas. So a little bit of fun, and that's ahead of the Christmas video updates, video countdown, beginning on the 1st of November. But at 1 hour, it's time for me to wrap things up and say thanks so much for watching, and come back later on for that final written update for Christmas. That's it for now.